Hi guys, so this is the first lesson that I'm going to be doing for y'all, and it will be regarding logic gates, right? So I'm not going to do the whole lesson starting from the basics and then going on through the whole lesson descriptively. Rather than that, I'm going to be doing a question, right? So that you can understand how the questions are made, and you can also understand how you're supposed to answer them, right? So there are very small things that we miss while answering questions that could actually cost us a lot of marks, right? And we have to realize the fact that logic gates, that's one of the most important things when it comes to A-level ICT, because there's always a lot of questions from logic gates, right? There's a few MCQ questions, and there's always a essay question, surely, right? So we'll get this done first of all, and when I'm going to start, I'm going to so I'll be telling you guys what the paper I'm doing is. So it's the 2014 A-level past paper, right? So it's the second part, part B, and it's the first question, right? So most of the time the first question is based on logic gates and boolean, right? So you can see the question here, and if you can't see it, you can get it from the internet, like you can get the paper and go through it, right? So first of all, I'll be telling you guys how to start doing a question, right? So the first thing that you have to do when you're doing a logic gates question is you have to find out how many inputs there will be for the circuit that you're going to make, right? So in this, it says that an alarm system has been designed to detect break-ins by using 3 detectors, right? So they're saying that there's only 3 sensors or detectors or inputs, right? So we have 3 inputs. That's we'll take them as A, B, and C, okay? And there's the alarm system, which is the output. We will take it as F, right? And one thing that you have to make sure to do when you're answering A-level questions is that you write down what these things are, right? We assumed that A is one input, B is another input, C is another input, right? So we have to make sure to write those things down. We have to write down what these things separately mean, right? So for this, there's something called the motion detector, glass break detector, and blackout detector, right? So blackout, motion, and glass break, right? So these are the 3 inputs, right? So I'm going to write down what these each mean in my circuit, right? So the blackout detector I'm going to take as A, and the other 2 B and C, right? And the alarm itself, I'm going to take it as F, right? And another thing is that in this question they're telling you that when a detector is active, it will send the logic value 1, right? But in some questions they don't say that, right? They just tell you that there's a detector. They don't tell you what 1 means and what 0 means, right? So in that case you have to write down those things as well, right? Like if the blackout detector is active, A will say 1. You have to write that down if it's not stated in the question. But since it's stated in the question in this one, we're not going to be writing that down, right? So the other thing you have to find out when you're starting off with the question is how many lines you have to write down in the truth table, right? So this is a very common thing and a very easy thing that people mess up because they don't know the basic way to actually find it out, right? So how you actually find that out is so there's you take the number of inputs, right? So in this case there's 3 inputs, right? So the number of lines that you have to write down is the number of variable situations that can actually happen, right? So it's always, in every case, it's 2 to the power number of inputs, right? So if there's only 2 inputs, it will be 2 to the power 2, which means 4 instances, right? So since it's 2 to the power 3 right now, because of the 3 inputs, it will be 8 instances, right? So I had to write down 8 lines, right? So 0 1 0 1 0 1 0 1. So that's 8. Okay, then the next one, all right, so we have the preparation phase for the question done, right? So now we're going to be doing the actual logical part of it, right? So in the question it says the system automatically detects a break-in and triggers the alarm, which means sends the logic value 1 only when all the 3 detectors are simultaneously active, or the blackout detector and any one of the remaining detectors are active, right? So this statement is what describes the whole system, right? So it says that all 3 uh, logic the all 3 of the detectors should be saying 1, right? All 3 of the detectors should be active simultaneously for the alarm to actually go off, right? So that only happens over here, right? All 3 detectors working. So that will be this, right? So in the F column, which is the alarm column, we're going to write down 1 because it's going off when all 3 detectors are active, right? But it also says that the blackout detector and any one of the remaining detectors are active, right? In that case also the alarm will go off, right? So since we said that A is the blackout detector, right? So this states that if the blackout detector is active, which is this area, right, and any one of the other detectors are active as well, which is this and this, right? See, the blackout detector should be always on for the alarm to go off, right? And while the blackout detector is active, if at least one of the other 2 detectors are working, the alarm will go off, right? So these 2 will also say 1 and the rest will all be 0. Alright, now that we've written down the actual instances where the alarm will go off, we're done with the truth table part, right? So we're going to go ahead with the deriving of the Boolean expression, right? So that's what the question says. Construct a truth table, and then it says that we have to derive a Boolean expression to represent the truth table constructed in section A, right? So when we are deriving the Boolean expression, make sure that you write these things down, right? Don't just do it in your head and then write down the expression. Since it says derive the expression, you have to write these things down, even though you can easily figure it out in your head, right? So this is a place where we always miss marks, right? So when you're deriving the expression, what you have to do is you have to mark the places where the circuit is actually working, right? Where the system is working, which means 1, right? This is so I'm doing this in the sense that we are doing a SOP1, right? Sum of products, right? So if you're doing it in the POS way, the POS way, you'll be taking into consideration the zeros, right? So since it's most of the time it's SOP that we have to do because that's the easiest way, right? We'll be doing it in SOP. Okay, so we have to mark the ones that are actually active, right? So you mark those things and then you sort of put an arrow on that and then you write down what these things actually mean, right? So it says 1 0 1, right? So those are the inputs, right? So 1 for A means A, 0 for B means B bar, right? And then 1 for C means C. So that we're going to write down as A B bar C, and the next one is A B C bar, right? And the next one is A B C, right? So this is the deriving part of it, right? So after that we write down F equals A B bar C plus A B C bar plus A B C, right? So this is the derived expression, the derived Boolean expression for the function of the alarm system. Okay, so now that we've done it in SOP, I'll quickly show you guys how to do it in POS, right? Because in some questions they specifically tell you to use the method product of sum, right? So we'll be doing that here. So ignore these things, right? Ignore this part and this part, right? So when you're doing the deriving of the expression using POS, what we do is we imagine that 0 is 1 and 1 is 0, right? You take the inverse of this, right? So just like you did in SOP, you mark down the ones, right? But since I said that you have to take the inverse, we'll be actually marking the zeros, right? So these are the things that we will be marking, right? So we use pos for instances where there's only a few zeros and a lot of ones, right? So the things that we have to write down are less, right? So but in this case there's a lot, so we should be using SOP. But all right, so just like we did here when we were doing it in the sum of products method, while we are doing it in the product of sum methods, what the difference is going to be, the symbols are all going to be the inverse, right? So when you're writing down this part over here, we will be writing it down like this, right? So get the arrows down, right? And when you're writing it down, you take the 0 as the 1 and the 1 as the 0, right? So A0 means actually A, not A bar, right? And since it's the product of sum, we're going to be writing it down in this manner: A plus B plus C, right? See, this is a sum, right? Plus plus plus, that's a sum. This is a product, A into B bar into C, right? So that's what these things mean. Sum of products means this is a sum of products, right? So when you're doing a product of sum, it's going to be the other way around, right? So I'll quickly write this down: A plus B plus C bar, since this is 1, right? And we're taking the inverse: A plus B bar plus C, A plus B bar plus C bar, A plus B, A bar plus B plus C, right? So those are the product of sum outputs, right? So you take those and then you write down F equals A plus B plus C, A plus B plus C bar, A plus B bar plus C, and A plus B bar plus C bar, and A bar plus B plus C, right? So if you simplify these, you can figure out the fact that this is actually equal to this, right? So these things are the same but written in two different methods, right? Ideally, the product of sum method is used in an instance where there's a lot of ones here, right? If there's a lot of ones here and like 1 or 2 zeros, then this will be very short, right? The expression that you're writing, that's the reason that we have product of sum, right? I just wrote it down in this way so that I'll sort of give you a brief instruction as to how do pos, but it's only used in an instance where there's a lot of ones and a few zeros, right? All right, so now that we're done figuring out what the expression that we need to simplify is, and the next part of the question says that we have to simplify the derived Boolean expression, we will be simplifying it, right? So one thing that you have to make sure to do when you're simplifying a Boolean expression is that you have to write down all the laws that you will be using, and these are the specific laws that I will be using to simplify this expression, right? So I'll be writing it down. And now I will be simplifying it. Sorry, A B bar C, right? I wrote down this, and then I can switch these things, right? So I'll be switching this over here, A B C, right? And then I'll be writing down this one. And since x plus x equals x, I can write this as ABC plus ABC equals ABC, right? That means I can repeat this term. So I will be repeating it over here, right? And then after that I will be using this law, right? This one. So it says that y into x, x into y plus c is equal to xy plus xc. So I can, if I use the inverse of this, I'll be writing this down as AC into B bar plus B, right? And the same thing over here, plus AB into C bar plus C, right? And now I'm going to use this law, x plus x bar equals 1. In this case, these things will all be 1, right? And since x into 1 equals x, this into 1 equals this, right? So it will come out as AC plus AB, right? So after this, you can actually take out A and then put C and B into one bracket, such as this, A, B plus C, right? But that's actually not that necessary, right? You can write it down like that, and there's nothing wrong with writing it down like this, right? But when you're using K-maps, this is the expression that you will get, right? So the other thing is, when simplifying a Boolean expression, the most reliable and easiest and fastest way is to actually use a K-map, right? I'll be teaching you how to use K-maps, how to go through the whole K-map process in a bit. But right, so the reason that I said that this is the answer that you'll get from K-maps is because using K-maps is the most reliable and fastest way to actually find out the final answer that you're supposed to get when you're simplifying a Boolean expression, right? But since the question says that I have to use Boolean algebraic rules, I can't use the K-map here. But what I always do is I draw a K-map and find the actual final answer on a piece of separate piece of paper, so that I know what to expect as the final answer for the simplification, right? Then you can get a clear idea about how to work your way through the whole simplification process, right? So you could use that method as well, because it's really fast and you don't have to spend a lot of time trying to figure out what this will actually lead to, right? And you can actually be sure about the answer that you get because you have a second opinion, right? The K-map, right? So you could use that method if you're very used to K-maps, right? So I'll be teaching you guys how to use K-maps after we finish this question, right? So the next part of the question is to construct the logic circuit for the simplified Boolean expression, right? So we will be constructing the logic gate for this, right? And we will also be drawing it for this as well, right? So there's two ways to actually draw logic gates. You can either draw it like this. I'll draw the two expressions in the two methods, right? So one method, I will be using it for this, is to just draw it like this: A, B, C, right? Right? Don't mind the drawings being messy, because I have to hold the camera with one hand. I can't actually focus on this, right? Okay, so you can actually draw it like this, right? So this is A, B, right? This is AB, this is AC, and this is AB plus AC, right? So that's the output, which is F, right? You can draw it in this way, or you can draw it in the other method, which is you put down all the inputs like this, right? And then you draw it. Right? So this is this expression. This is B plus C. This is A. So it will result in A into B plus C. Right? So this is the end of the question, right? There's another part where you have to explain um, a statement, right? So the statement is that the alarm will only trigger if the blackout is actually happening, right? So that is very clear. They are asking whether you agree with it or not, and it's very clear that it should be agreed to, because this is the blackout sensor, and all the instances where the alarm is actually going off, the blackout sensor is one, right? So you do have to actually accept that, and you have to explain it, and stating that the alarm only goes off if the blackout sensor is actually going off. That statement would suffice, right? So that's the end of the actual logic gate question that we are doing. So I hope that you got a clear understanding about how to work your way through the question, right? So after this I will be moving on to k-maps. About basically I'll be doing the whole k-map segment, because something that I've seen is a lot of people actually mess up the K-maps because of very simple things that they missed while they're actually learning them, right? So I've detected some of these mistakes that you all make, so I can actually show you these things. So I hope that this will be helpful for you all. I will be uploading the K-map video in a little while. So yeah, thanks.